Okay, so here's the answer to the question 1. Z equals to x plus y. So capital F of z equals to the probability that z is less than or equals to z. This equals to the probability that x minus y is less than or equals to z. So this probability equals to the capital F x minus y, and it's also equals to the double integral of little f(xy) of xy. Here we can draw the graph of the region of convergence. So here, this line is y equals to z minus x. So this line. And the length of this line is z, and the length of this line is z. So it has to be in this part here. Here is y is less than or equals to minus x plus z. So here, because we already know the capital F of z equals to this. So here, we derive we can get the little f z of z. So that is the integral of f x y of x y, and then we can substitute x with z minus y. So this becomes the double integral of z minus y, and here it also equals to the x from minus infinity to infinity fxy, x z minus x. So this is because this can be similar to this. So we can get this. So here, we rewrite this equation in this way. The integral of xy, z minus y, equals to the integral of fxy, fx z minus y, fy of y, and it also equals to fxz times fy of z. Similarly, we can also rewrite this, you see, this equation, we can also rewrite this equation in this way. The integral of fxy of xz minus x equals to fy of z times fx of z. So this is the first method, and then here, and the second method, we want to use the step function. So the capital F of z equals to the double integral of fxy of xy, and here we can add u of z minus x plus y here, because this doesn't bother the function of this function. So we can add this part, and then we can write this as this way. The capital F of z equals to the double integral of fxy of xy, u of z minus x minus y, because we want this function be meaningful. So this part u of z minus x minus y has to be greater or equal to 0. So this means this part, because this part only when z minus x minus y is greater than or equal to 0, u of this can be meaningful. So this is also the region of convergence in this question. So here we rewrite this because we already know the region of convergence is when y is less than z minus x. So when we integrate it, the y becomes from negative infinity to z minus x. So here, the capital F of z can be written in this way. And similarly, we substitute x. Here we substitute y with z minus x. And similarly, we just need to substitute x with z minus y. So we can get the capital of z can be also written in this way. So because these two equal, and then when we want to get the little f of z, so we need to differentiate the capital of z, and here we can get the little f of z equals to the integral of f(x,y) of x z minus x, and also equals this. So here when we get this, we come back again to the first method, and we already proved it right. So here it's also right. So it gets proved.